Hello, this is Francisco Burgos, and I'll be talking to you about my project 2 for ENGI340, and the model and the problem will be over manpower planning. So what is manpower planning? It is the activity of determining the number and types of personnel required by a company or an organization to carry out future work. So I know that as a CEO or leader of a company or factory, I would want to hire some quality workers that work at a high performance. And so some reasons for choosing this topic is, like I said, I like to help in the future, possibly with my education, a company to perform at its maximum potential at a low cost while having quality workers who work at their max potential and make the company look good. In this, another reason why I chose this topic is because earlier in the year, Professor Hom was telling us about an issue going on currently where companies and factories are buying more and more machines to put in their factories to do jobs that we could do. But the thing is that the machines can do it much quicker, much faster. And so we're losing our jobs. But in this problem that you're about to see, a company wants to actually hire workers, and based on their skill levels, they will retrain them to reach a higher skill level so they can retain their job, or just downgrade them to a position that they can manage easily. So in the problem description, here's something brief. A company is undergoing a number of changes due to the fact that there's going to be a downturn in trade in the expected year. So since there's a downturn in trade, there is going to be a reduction in the workforce in all categories, meaning unskilled to semi-skilled to skilled workers. And so a method that the company is going about is by recruiting employees and retraining them. So for unskilled workers, they will be trained to be semi-skilled workers, and at a cost of 400 euros per worker. And then there's semi-skilled workers that can be trained to be skilled workers at a cost of 500 euros per worker. And then the last option is downgrading workers, which has no cost, which is actually beneficial to the company since they don't have to put money towards that. So with this, the company has to take into account what specific employees are waste, or the projection, how the projection and past projections have been with employees who leave after a certain time working in the company, and also seeing overstaffing, short staffing, and meeting the limits of retraining for each category of workers. The objective of the company is to be able to perform this method of recruiting and then retraining while reducing costs as much as possible and the redundancy payment to workers. So here are some variables: the strength of labor force. So here's the total labor force of each skilled level at that certain year I. Then there's the recruitment of each skill level at that certain year, and then the retraining of the skill level, such as unskilled workers retrained to semi-skilled. Then there's the downgrading, as I said, that has no cost. And then here's one of the objectives, is to reduce redundancy, the payment of workers, and then there's short timing, overmanning. Now the constraints given: continuity, retraining semi-skilled workers, overmanning, and the requirements. Here we can see that in retraining semi-skilled workers, the amount of semi-skilled workers retrained to become skilled workers has to be a quarter less than the current force of the skilled workers. Overmanning, basically the company can employ up to 150 people for each group, but going over will cost differently for each skill group. And then up to 50 workers of each class can be put in short-time working, meaning that they will basically work half of the amount they already work. And that will cost the company still some money. So the comparison of as is and to be, when minimizing objective 1, which is reduce of redundancy, the model was able to reduce it to 842 workers, and by following the policies, they reduced it to a total of 1,438,000 for the total cost overall. Then with minimizing objective 2, which is the total cost, you're able to reduce the total cost down to 498,000, but the redundancy goes up to 1,400. So in this current model given, it is only based on capacity constraints, and capacity is being multiplied by cost, and that's it. So here we can look at the original, where minimize weight redundancy times redundancy plus weight cost times weight cost. And here's a subject 2 pertaining to the matter of class, and that class per year. Basically everything is pertaining to what class and the year, and of course they have their constraints, as you can see right here. Overmanning, required staffing, initial conditions, the redundancy, which is a big thing in this model. They focus it on a lot, as well as capacity constraints. So one thing I did was I did some research, and I came upon these articles about modeling for optimal manpower size using linear programming modeling, which we are currently doing in our class, or this project in OPL. And it gave me ideas for maximizing profit, and not only that, but as well as some variables I could use and some methods, as well as in this one. Evaluation of models, max P, gave me some good examples. So instead of looking at capacity constraints, we look at constraints based on performance at each skill level. Looking at skill level, each worker can have a low, medium, or high performance rate. And based on their performance rate, revenue comes in, which means there's benefits that can outweigh cost or so. And then workers have constraints on hours of operation and production rates at which they can perform. So the mathematical model as is where they want to reduce the sum of redundancies, and then objective 2, minimize the sum of costs. And that's how the model is, and the one I just showed you in OPL. No mathematical model to be. It could be, since I'm trying to base it on performance level, and then based on that performance level, how much revenue comes in, and as well we have to take into account the cost of each performance level workers, meaning cost high, cost medium, cost low performance, and then revenue right here, as well as taking the cost of the whole method. So we're trying to maximize profit, or see how much more less we can make this method cost. And so we go into OPL, and we can see that this model here is heavily based on redundancy and cost. So everything is based with like this